morning, students. In the last session we have studied about the heating effect of electric current. Here now we are going to discuss the practical applications of heating effect of electric current. See, the heating effect of electric current is also known as Joule's heating. See, the generation of heat in a conductor is an inevitable consequence of electric current. So in so many applications it is undesirable as it converts the electrical energy, the useful electrical energy into the heat. We don't need the heat in all applications. However, the heating effect of electric current has so many practical applications. For example, in electric laundry iron, electric toaster, electric kettle, electric oven, electric heater, in all these cases, we need to produce the heat. These are the applications of heating effect of electric current. Then another application is in the electric bulbs. See, all of you are familiar with these types of bulbs, isn't it? So in this one, a filament, you can see the filament which will get heated and it will produce the light. But these types of filament is made of a strong metal which has very high melting point. Due to that reason, it will become red hot condition very much time, but it will not break. For that purpose, normally they are using the strong metals like tungsten. Bulb is filled with the electric bulb. It's also known as incandescent bulb. That is a bulb filled with chemically inactive gases like nitrogen, argon in order to prolong the life of filament. But the disadvantage of using these types of electric bulb is most of the electrical energy which is used to produce the light is getting converted into heat. For example, if 100% we know that 100% electrical energy is reaching the bulb, but around 60% will be converted into heat, and remaining 40% is converted into light. See, our purpose of using the electric bulb is to produce the light only, but most of the energy, the useful electrical energy is converted into heat. So that's the reason why these types of bulbs were replaced by the CFL and other LED bulbs. The reason is the LED as well as the CFL bulb has more efficiency than the incandescent bulb. The next application is electric fuse. See, electric fuse is a device used to protect the electric circuit and appliances by stopping the excess current flowing through the circuit. See, each and every appliance has its own current rating. Okay, if the more current passes through the device, then it will damage the device. In order to stop that problem, what we will use the electric fuse with the devices. But there is one condition: electric fuse must be connected in series with the electrical devices. And you might have seen the shape of the in small devices. You can see the electric fuse like this. It will consist of a metal wire. The main purpose of fuse in order to stop the circuit, break the circuit if the excess current flows through the circuit. For that purpose, we have to choose a metal wire which has very comparatively less melting point. When the excess current flows to suppose the power rating of this metal wire is 5 ampere. Let it be 5 ampere. If more current, more than 5 ampere flows to the circuit, it will damage the appliances. For example, TV. These are just figures. Here also this is not a current figure, and I'm just giving a number in order to make you understand. So 5 ampere is the maximum current that can be flow through a TV. Consider the TV. Then we will connect the fuse with the TV. If excess current means, for example, 6 ampere flows to the circuit, then the fuse wire will become red hot condition and it will melt, isn't it? Then the circuit will break, thereby we can protect the electrical appliances. I hope you understand the working of electric fuse. See, for filament of the electric lamp, we are using the metals with high melting point, and for the fuse, normally we will use comparatively less melting point. These are the differences. Dear students, now we can move to the next topic, that is electric power. In previous classes you have studied that the rate of doing work is known as power. Here we are discussing about the electric power. I will explain it in a simple way. See, all of you know that electrical energy is needed to work in order to operate all the electrical appliances, isn't it? So how much electrical energy is used by a device in 1 second? How much electrical energy used by the device in 1 second is known as electric power of that device. So that's the meaning of electric power. Now we can define the electric power. The rate at which energy consumed or dissipated in an electric circuit is known as electric power. I will repeat. The rate at which the electrical energy is consumed or dissipated in an electric circuit is known as electric power. So we can represent the electric power by the symbol P. The normal equation, this one you have studied in the previous classes, P equal to work done, power equal to work done by time. Here the electrical work done. So we can write P equal to W by T. Work done is represented by small letter w and time is represented by T. See, in the previous cases we have studied work done is stored as energy. What type of energy? Heat energy. So we can replace this work done into heat. So our equation is this equation you have studied in the lower classes. So P equal to h by t is our new equation. P equal to h by t. P equal to w by t is the standard equation. Here the new equation is P equal to h by t. If you get confusion, just make sure that the SI unit of heat energy as well as the work done is same. That is Joule, isn't it? So power equal to h by t, our new equation. This is first equation for the power. P equal to h by t. Just substitute the values in the equations for h. There are three equations you have studied in the last class. H equal to I square RT, H equal to V I T, H equal to V square T by R. See, P equal to H by T. That means you have to divide the equations of heat by time. So simply just in order to get the power from this equation, just replace heat times from this one. Then you will get equations for power. Then if you remove T from the first equation, you will get P equal to Vi. So this is next equation, and from this equation if you remove the T, then you will get P equal to V square. So here P square by R, and third equation P equal to I square R. Okay, so how many equations you have to study? This is when you write the definition, you have to write this equation P equal to Vi, otherwise P equal to H by T. Okay, then all these three equations are there. Total 4 equations, 1, 2, 3, 4, and one more equation is there, that is work done by T. Okay, total 5 equations are there. Depends on the question, you have to use this. You have to choose the correct equation. So we have defined the name electric power, and we have written the equations of electric power. Now we can move to the SI unit of electric power. The SI unit of electric power is what? It is represented by the letter capital W. See. Now in practical applications we use the larger unit. This one is smaller unit, so we will use the kilowatt. 1 kilowatt equal to 1000 watt. 1 kilowatt is equal to 1000 watt. That's a higher unit of watt. Now once we define the quantity, then we will write the equation. Then we will write the SI unit. Now we have to define the SI unit. That means define 1 watt. See, before going to that, I will simply say 1 watt. From this equation, what we can write? From these two equations, we can mention 1 watt. 1, the unit of power is watt. So 1 watt equal to, what is the unit of heat? That is Joule. Then what is the unit of time? Second. So 1 watt can be written as 1 Joule per second. This equation is not mentioned in your textbook, but you can expect the choose the correct answer question for the board exam. So 1 watt equal to 1 Joule per second. This is one option. Then according to the definition of watt, use this equation P equal to Vi. What is the unit of potential V? That is volt. Then what is the unit of current? That is ampere. 1 watt can be defined as 1 volt into 1 ampere. 1 watt, in textbook we have to use this equation. Using this equation we will define 1 watt. 1 watt equal to 1 volt into 1 ampere. That's the reason I am not writing 1 2 times. That's the reason we can write 1 volt into ampere. So we can define 1 watt. 1 watt is the power consumed by a device which carries the current of 1 ampere and operates at a potential difference of 1 volt. 1 watt is the power consumed by a device which carries current 1 ampere and operates at a potential difference of 1 volt. Is it clear? Now we can move to the last topic, that is electrical energy. See, the electric energy from the previous section we could find that power equal to W by T. The unit of work as well as energy same. So we can replace this work with energy, that is P equal to E by T. Then just replace this equation in order to get E. Then when we E equal, then E becomes equal to P into T. So what we can say, electric energy equal to P into T. We can define electric energy as a product of electric power and the time, that is E equal to P into T. What do I mean by electric energy? It is the product of electric power and time. So the SI unit of electric energy is watt hour. How we are getting the watt hour? P. The unit of power is watt and time is hour. We will not consider about the second case because electric energy is used by the devices will be different with high value. So we will consider only the large value for the time. Then once we set the unit of electric energy is watt hour, we have to define that. 1 watt hour is the energy consumed when 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. Then when we can say the electrical energy used by a device is 1 watt hour. That means the electrical energy used by a device is said to be 1 watt hour when 1 watt of power is used by the device for 1 hour. If a device uses 1 watt of power for 1 hour, then we can say that the electrical energy used by the device is 1 watt hour. But in commercial purpose, we use the another unit. The commercial unit of electrical energy is kilowatt hour, because you know that so many for commercial purpose we are using very large machines, so it will use that much energy. So we will use the another unit. The commercial unit of electric power energy is kilowatt hour. 1 unit of electric energy means the kilowatt hour in our domestic purpose. So the commercial unit of electric energy is kilowatt hour. So we can convert the kilowatt hour into what? Joule, because energy, the unit of energy is joule. The 1 kilowatt hour. See, first we have to convert the kilowatt into watt. Kilowatt means 1000 watt. So we have written 1000 watt in. Now we have to convert the time, that is hour into second, 60 into 60. So we will get the values in SI units of power as well as the time. So we can write 3.6, that is 3600 second into 1000. Then you will get 3.6 into 10 raised to 6 watt second. So 1 kilowatt hour will be equal to 3.6 into 10 raised to 6 watt second. And this watt second means joule. How we are getting? See, E equal to P into T. The unit of electrical energy is joule. Then B equal to watt and time equal to second. These are the SI units. So we will get 1 kilowatt hour equal to 3.6 into 10 to 6 watt second. And we are just rewriting that we are replacing that 1 watt second equal to 1 joule can be defined as 1 watt second. So we will get 1 kilowatt hour equal to 3.6 into 10 raised to 6 joule. So we have completed the chapter and you will get the idea how to solve the problem. Try to solve the problems yourself. Okay, thank you.